Welcome back to Mr. Hassan's Maths channel. This is question number 9 from the October-November 2021 paper 4 variant 2 IGCSE Cambridge 0580 exam. This question here is about vectors. Part A, 1, tells us first f is the point 5, negative 2, and the vector from f to g is negative 2, 3. Find the coordinates of the point G. So we've got to find the coordinates of the point G, and in order to do that, what we can do here is we can understand that the vector f to g tells you how to go from f to g. Okay, it tells you what to do if you want to go from f to g. So if we start at f, which is at the point 5 of negative 2, that's the point f, and we want to get to g. It's telling us to get there, we have to go 2 units to the left. That means the x coordinate has to go down by 2. And we have to go 3 units upwards. That's what this vector means. The number on the top is basically how much you move horizontally. So if it's negative, you move to the left. And the number underneath is how much you move vertically. So if it's positive, you move up. So you have to add 2 to subtract 2 from the x coordinate. That's going to give you 3, and you have to add 3 to the y coordinate. That's going to give you 1. So 3, 1 are the coordinates of the point G. Okay, simple as that. Number 2 is also equally as simple. It tells us to find the vector 5fg. Now 5fg is where you take the vector f to g and you multiply it by 5. When you multiply it by 5, it's just 5 times as long. So it's going to be 5 times minus 2, which is negative 10, and 5 times 3, which is 15. Again, very simple little question there. And part 3 is asking you to find the magnitude of the vector f to g, the length of the line from f to g. And as I said, if you want to go from f to g, you have to start at f, go through 2 units to the left and 3 units up. So it's going to have some sort of look like this. This will be the vector from f to g. It's just a little sketch of it. So we've gone 2 units to the left and we've gone 3 units up. So we have basically 2 units to the left, sorry. You have, what you form here is basically a right angle triangle with sides 2 and 3 other shorter sides. So what we're going to do is we want to find the magnitude of this length of this line. So we can use Pythagoras. So it's going to basically be the components squared and added together. And you don't have to worry about the sign. Okay, you don't have to worry about negative 2, because negative 2, when you square it, gives you the same as positive 2 squared. So it's going to give you the square root of 4 plus 9, which is 13. So we got the square root of 13, which we're going to round to 3 significant figures to give us the answer that we need. So we'll do the square root of 13, which gives us 3.6055. Which is 3.61 to 3SF. Okay, root 13, 3.61. Non-exact answer should be rounded to 3SF as instructions tell us. So there's the answer to part 3. Very simple. Part A, 1, 2, and 3. Now we're going to go on to part B, which is more to do with vector geometry. It says OABC is a parallelogram. Okay, a parallelogram has sides which are parallel and equal in length. That's important for us to realize. And it says P is a point on AC, and Q is the midpoint of AB. So this means it's this A to Q and Q to B are the same length. All right. It says O to A is a vector A, and O to C is a vector C. It says find in terms of A and or C, A to Q. Now A to Q is part of the line A to B. And I know that the vector A to B is the same as the vector O to C, because this is a parallelogram. The opposite sides are equal and parallel. So the vector from A to B will be the same as the vector from O to C, the same length and parallel, so that's equal to C. And Q is the midpoint of A, so therefore I can say that the vector from A to Q is going to be a half of the vector from A to B, which is a half of the vector from O to C, as we said. That means it's a half of C. So it's a half of the vector C. Okay, there's the answer to part A. Part B says find the vector from O to Q. Okay, O to Q. If I want to go from O to Q, I've got to go from O to A, and then I've got to add to that from A to Q. Okay, so if I want to go from O to Q, I've got to go from O to A and then from A to Q. Right, now I already worked out what A to Q is. That's a half C. So O to Q is going to be O to A, which is A, plus A to Q, which is a half C. So there's the answer, A plus a half C. All right, so far, very simple. Now, this is now part 2. Okay, this is now B part 2, part A of part 2. It says, show that O, P, and Q lie on a straight line. So we'll show O, P, and Q are all on a straight line. Now, I have the vectors from O to P. They told us it just now, 2/3 A plus 1/3 C. And I also have the vector from O to Q, which is A plus a half C. Now, if I want to show that these two vectors are on a straight line, I have to show that the vector from O to P and the vector from O to Q are in the same direction. I have to show that they are in the same direction. Okay, to do that, I need to try to take out the fractions from these terms and factorize out the fractions, you could say. So I have to make the denominators the same, okay, in each of these. So these here, the denominators are already the same. So I can take out the common factor from the numerator, which is 1, and the common factor from the denominator, which is 3. So I can take a third out, and inside the bracket I'm left with 2A, because a third times 2A is 2/3 A, plus C, because a third times C is a third C. And I can do the same for O to Q, but what I have to do first is I have to try to get rid of the fraction from here. So what I could do here, in fact, what I can do instead of that is actually an easy way of doing it, actually. Okay, what I can do is I could get rid of the fractions from here by multiplying both sides by 3. This is actually an easier way of doing it. If I multiply both sides by 3, the fraction's gone. So I've got 3O to P is equal to 2A plus C. I've just multiplied both sides by 3. And if I want to get rid of the fractions from all of this, I can multiply both sides by 2. This is, in fact, an easy way of doing it. So if I multiply both sides by 2, I'll have 2 times O to Q is equal to 2A plus C. Now we can see that these two are equal to the same vector. Okay, so they're both equal to the same vector. They're both multiples of the same vector. So I can say that 3 times O to P is the same as 2 times O to Q. Right, so we could say, for example, that O to P is 2/3 of O to Q. So therefore, what can we say? That O to P and O to Q have the same direction. Okay, and pass. Okay, O to P and O to Q also pass through O. Okay, I'll say both pass through O, just to make it clear. They have the same direction and they both pass through O. Therefore, O, P, and Q are collinear. That's what collinear means. Collinear means they share the same line. They lie on a straight line. So I could say O, P, and Q lie on a straight line. Just use the word collinear short. Okay, so that's how we can prove. If you can prove two vectors are like multiples of each other, like we have here, then we know they have the same direction. And if they both pass through the same point as they do here, that means they're both. Then the points must be on the same straight line. Then it says write down the ratio of O to P and O to Q. Give your answer in the form 1 to n. So O to P and O to Q. Sorry, you have this line. There's O, there's P, and there's Q. So O to P was 2 parts and P to Q was 1 part. So O to P and O to Q. Okay, so we can say that the ratio is 2, and from O to Q is going to be, that's going to be 2 to 3. Okay, that's 2 to 3, but we want it in the form 1 to n. So we divide by 2 and divide by 2, so you're left with 1 to 1.5. So it's 1 to 1.5. That's the answer for part B. They want the ratio of O to P to O to Q, which is 2 to 3, which if you want it in the form 1 to n is 1 to 1.5. Not in the simplest form, but in the form 1 to n. So that is the answer for the last part there of this question, and that concludes the question number 9, which is all about vectors from this paper. Other questions from this particular paper can be found in the playlist that should appear in this region over here at the end of the video, and you can find other questions which are related to vectors from IGCSE Maths in this playlist that should appear in this area, and you can subscribe to my channel by clicking on the link in the middle. Thank you for watching. See you soon.